Hi everyone, in this video I'll be explaining how you can integrate using trigonometric substitution. This method consists of 4 steps I've described here, and there are some things you need to memorize, which are these 3 expressions, which are for step 1, which is identifying the trig function, which is one of these 3. I believe this technique is easier to learn simply by practicing, and this will get examples than rather listening to me give an explanation of it. So I'll get straight to the first example. Okay, step 1, identify trig function and build a right triangle. So we need to match this integrand with one of these 3 trig functions. And to do this, let's look at the polynomial expressions that we have here. And you'll notice that the numerator looks a lot like a squared minus x squared. So let's get right into it. Let's identify a, which is 3, because a squared is 9, and 3 squared is equal to 9. And for x, we have x squared and x squared, so x is simply x. And from this, we can sub in for x over a in the sine equation. So we know that sine of theta is equal to x over a, or x over 3 in the case of this problem. And from this, we need to build our right triangle. And always, when building your right triangle, you want to put theta here and your right angle right there. Okay, so we know that sine of an angle is the opposite over hypotenuse, so we know that the opposite side has to be the x, and the hypotenuse has to be 3. And from basic Pythagorean theorem usage, we can determine that this blank side is, let's see, so that's blank squared plus x squared equal to 3 squared. So the blank squared is equal to 9 minus x squared, and the blank is equal to the square root of 9 minus x squared. And you'll notice that this is the same term as the numerator, and you'll notice that whatever goes on the final side is the polynomial that you have to use trigonometric substitution for. Now, we can go on to step 2 and identify what x and dx are. And for this, we'll be working with the trigonometric expression we have here. Okay, so simply we can just carry over the 3, and that gives us x is equal to 3 sine of theta. And we can just find the derivative of this equation to find dx, and dx would equal 3 cosine of theta times d theta. Okay, now that we have x and dx, we just need to sub in for x's and the dx's in the integrand with values of theta. So the numerator will equal 9 minus x squared, which would be 9 times sine squared of theta. And that is all over x squared, which we know is 9 sine squared of theta. And dx is 3 cosine of theta times d theta. Now, we can get into step 3, which is using trig identities to simplify this integrand. And you'll tend to notice that whatever you sub in for x, and when the x is paired with a constant, in the case of this problem, this numerator, you can pull out the term in front of the trig expression, and that'll allow you to use trig identities to simplify it. So let's just get right on with it. So I'll write the basic trig identity I'll be using. And let's pull out 9 from the inside the radical, and that gives us the integral of square root of 9 y minus sine squared of theta over 9 sine squared of theta, all multiplied by 3 cosine of theta d theta. Now, we know using this basic trig identity that 1 minus sine squared of theta is equal to cosine squared of theta. So that means this integrand is equal to 9 cosine squared of theta over 9 sine squared of theta times 3 cosine of theta d theta. And we can simplify the numerator, which gives us 3 cosine of theta over 9 sine squared of theta times 3 cosine of theta d theta. And simplifying it once more, we know that 3 times 3 over 9 is 1, so we can just eliminate those constants, coefficients, and that gives us the cosine squared of theta d theta all over sine squared of theta. And we can simplify this to turn the integrand into cotangent squared of theta d theta. Now, we need to integrate cotangent squared of theta, but that is not a basic integral, and as a result, I'll be using trig identities to transform it into an integral that I do know. So using this, we can find cotangent squared of theta by dividing everything by sine squared of theta, and that gives us cotangent squared of theta plus 1 is equal to cosecant squared of theta. And from this, we can determine that cotangent squared of theta is simply cosecant squared of theta minus 1. And that means this equals cosecant squared of theta minus 1 all multiplied by d theta. And the integral of this expression equals negative cotangent of theta minus the integral of 1 is simply theta, and then plus c because it's an indefinite integral. And moving on, we just need to substitute theta for values of x, as step 4 says. Okay, and to find theta, we have to work with the original trig expression right here. So from this, we can determine that theta is equal to the arcsine of x over 3. And for cotangent of theta, we can find tangent of theta in this triangle, and that would mean the tangent of theta is opposite over adjacent, which is x over square root 9 minus x squared. And that means the cotangent will simply be the flipped version. Okay. Let's bring this down. And then we have cotangent. Sorry. Okay. Now we can sub in for cotangent of theta. So we have negative cotangent of theta, which would equal square root of 9 minus x squared over x, minus theta, which is arcsine of x over 3, and plus c. And that is the solution to this integral. So let's get right on with the second example. So this integral looks a lot like the a squared minus x squared. Oh, it is quite literally the numerator of this integral. Okay, so it shouldn't be too bad. So let's identify a and x. A is equal to 3, and x equals x. And we can build our triangle. Let's first replace x's and a's to find sine of theta. So we know that sine of theta is equal to x over 3. Okay. Okay, and that means this is x, this is 3, and then this is square root of 9 minus x squared, because that is the term that is giving us trouble. So let's get right on to step 2. What is x and dx? X is 3 sine of theta, and dx is 3 cosine of theta d theta. Okay, so let's replace the x's and the dx's with thetas. And that'll give us square root of 9 minus x squared, 9 sine squared of theta, times dx, which is 3 cosine of theta, d theta. And then we'll do the same thing we did in the other problem, which means we'll be doing 9, 1 minus sine squared of theta, times 3 cosine of theta, d theta. And then we'll use basic trig identities to simplify this. 1 minus sine squared of theta is cosine squared of theta. That's square root of 9 cosine squared of theta, 3 cosine of theta d theta. And that means this is the integral of 3 cosine of theta times 3 cosine of theta times d theta. So since 3 times 3 equals 9, and that is a coefficient, we can pull that out to the front, and that gives us 9. And then inside we'll have remaining the cosine squared of theta times d theta. Much like the cotangent squared of theta that I couldn't figure out the integral of, I'll be using trig identities to figure this one out as well. So in the case of cosine squared of theta, I will be using the half angle identity. And the half angle identity is the cotangent squared of theta is equal to 1 plus cosine of 2 theta all over 2. So I learned this when I was taking algebra 2, so you may have to look these up, but these are things you can memorize. So that means this equals 9 times the integral of 1 plus cosine of 2 theta all over 2 times d theta. And that is equal to 9 times the integral of 1 over 2 plus 1/2 cosine of 2 theta. All multiplied. We can simply find the integral of this integrand, and that means this would be 9 all times the integral of 1/2, which is 1/2 theta, plus the integral of 1/2 cosine of 2 theta, which would be 1/2 times 1/2 of sine of 2 theta, plus c, because it's an indefinite integral, and that gives us 9 over 2 theta plus 1/4 9 over 4 sine of 2 theta plus c. Now we need to sub back with x's for thetas, and let's see, theta, and we can use this. Then we get 9 over 2. Theta is equal to the arcsine of x over 3. Sorry, x over 3. Arcsine of x over 3 plus 9 over 4 of sine of 2 theta. But simply from this triangle we can't find it, so we have to use another trig identity, and this one states that the sine of 2 theta is equal to 2 sine of theta times cosine of theta. And that means we can write this as 2 sine of theta cosine of theta plus c. And let's just bring this down here, and that gives us 9 over 2 arcsine of x over 3 plus 9 over 2. Now, sine of theta from this triangle, we know that's the opposite over the hypotenuse. So that is x over 3. X over 3, and we need to multiply that by cosine of theta. In this case, it's adjacent over the hypotenuse side, which gives us square root of 9 minus x squared over 3, and then plus c. I'll just simplify this for you, and that gives us 9 over 2 arcsine of x over 3 plus, we can simplify this 9 by making it a 3 and making this 3 at the bottom a 1, and that gives us 3x square root of 9 minus x squared all over 6 plus c. And we can simplify this once more, and that gives us that over 2. And that is the answer. For the final example, I have the integral of dx over square root of 4x squared minus 1. So let's just rewrite this as the integral of 1 over square root of 4x squared minus 1 times dx. So let's get on to step 1 and identify the trig function it matches. And for me, it looks a lot like the secant of theta expression, because there's an x squared, which would be 4x squared, minus a squared, which would be 1. So let's find x and a. So x equals 2x, because 2x squared is equal to 4x squared. And a would equal 1, because 1 squared is equal to 1. And let's build our triangle. So the expression is secant of theta is equal to x over a, or in our case 2x. So that is the flip version of cosine, which is adjacent over hypotenuse, which means that this is the hypotenuse over the adjacent side. So this is 1 and this is 2x. And for the remaining side, we can just use the rule that I discovered of just the radical being on the final side. And let's make this square root of 4x squared minus 1. Okay, now we defined x and dx from this trig equation. So x is equal to secant of theta. Let's put a 1/2 in front of it. And the derivative of that to get dx is 1/2 secant of theta times the tangent of theta times d theta. Okay, now let's sub in for x's with thetas, and that gives us the integral of 1 over the square root of 4x squared, which would be 1/2 secant of theta squared minus 1, and times dx, which is 1/2 secant of theta tangent of theta times d theta. Let's simplify the bottom. We get the integral of 1 over square root of 4 times 1/4 secant squared of theta minus 1 times 1/2 secant of theta tangent of theta d theta. And let's do that once more, and then we have 1 over square root of secant squared of theta minus 1, all multiplied by 1/2 secant of theta tangent of theta. I'm just going to pull that 1/2 to the front, and we get this. And then I will be eliminating this secant squared of theta minus 1 using a trig identity. So let's just write it down. To get to secant squared of theta, I'll be dividing everything by cosine squared of theta. So that gives us 1 plus tangent squared of theta is equal to secant squared of theta. And that means secant squared of theta minus 1 is tangent squared of theta. That means this is 1/2 the integral of 1 over square root of tangent squared of theta times secant of theta tangent of theta times d theta. And obviously the square root of tangent squared of theta is tangent of theta. That gives us 1 over tangent of theta secant theta tangent of theta d theta. We can cancel these two out, and that gives us the 1/2 times integral of secant of theta. And the secant of theta is an integral that I do know, and that means this is 1/2 times the natural log of secant of theta plus tangent of theta. And from here, let's add that plus c. We need to find the secant of theta and then the tangent of theta from this triangle. As I said, the secant of theta is the flip version of cosine of theta, and cosine is adjacent over hypotenuse, so that would be 1/, 2x, but for secant it would be 2x. So let's see, 1/2 times the natural log of 2x plus tangent of theta, which is the opposite over the adjacent side, which would simply be square root of 4x squared minus 1. And let's put in the c at the end. And that is the solution to this final example. You just need to follow the steps, and with enough practice and memorizing these three rules and knowing your identities, your trig identities, half identities, and double identities, this should be a piece of cake after repetition.